Hey guys, I'm going to be explaining the different types of distribution. So, if you're looking at a normal curve, you have symmetrical distribution. You can tell because if you're looking at the ends right here, they're called the tails. And if one of them is longer than the other, usually that means there's a skew. So, if you look at a left distributed skew, and then a right and then a right skewed distribution, so the left skewed looks very similar to the right, just the opposite. But a way you can tell is by noticing that the skew doesn't refer to the peak, it refers to the ends. And so if your graph is skewed to the left, you can look for the tail and see which direction it's going in. Another difference between these two is that when it's going towards the right, it's positively skewed, and on this side it's going towards the negative numbers, so it's negatively skewed.
Hello, my name is David. I'm here to talk about mean versus median. First of all, I'm going to give you the definition of each word. The definition of mean is the average of the list of numbers that you have, or the centerness of the list of numbers, while the median is the middleness of the list of numbers. So first I'm gonna start off by showing off how to find the mean. And you find the mean by using this equation, sigma, the sigma of the number over the amount of numbers in your number list. So let's use this number list. 1, 2, 3, 4, 5. Okay, so to find the mean of this number list, you add, first of all, you add all these numbers up. So 1 plus 2 plus 3 plus 4, 5. And let's add that up real quick. You get 15. And so now, once you added all of them up, we divide it by the amount of numbers in your number list. So in this situation, you have 5 numbers. So you divide 15 by 5, which gives you a mean of 3. So that's how you find your mean. Now I'm going to show you how to find the median. The median, as you can see, like in definition, is much more easier to find than the mean. So the median is found by finding the middle number of the number list. So let's use the same one. 1, 2, 3, 4, 5. And keep in mind that when you're trying to find the median, you always want to have your list of numbers in order from smallest to biggest. So as you can see, this is already done here. So all we have to do is go one by one until we find the middle number. In this case would be 3.
Hello, this is Jared de Guzman. I'll be showing you an example of a positive skew. So for my example, I'll be using NBA player contracts. So most players in the league make about, I'd say 1 to like 10 million. That's like the highest. But there's like select few players, like superstars, that make over 30 million. And you would think LeBron is the highest paid, but it's Steph Curry, and he's paid about 35 million. Just over 35 million. To be exact, it's 37 million, which is kind of crazy. And million, here we go. And then you can tell this is a positive skew because the hump is on the left, and as you can see with the arrow, the long tail is towards the right side. With a negative skew, you would see the hump on the right-hand side and the tail on the left. Thank you. That's it for my example.
All right, so we are going to be discussing symmetrically distributed graphs in this example. So let's say the professor handed out an exam, and on that exam, people either got a 50, 60, 70, 80, or 90. 3 people got a 90 or a 50. 5 people got a 60 or an 80, and 10 people got a 70. So we want to use the median to describe the centerness of this graph, which would be 70, because hence the name of a symmetrically distributed graph, there are equal amounts on the left side and as there are on the right side. Unlike where in Jared's example, there were a lot of results on the left side and there's one outlier on the right side. So in that instance, it would have been best to use the mean because this outlier would have thrown the centerness of that curve off. Whereas here, there's no outliers to throw off the centerness of this graph, so the median would be ideal to describe the centerness.